Hey students, in this video we're going to go through section 10.3, which is about shapes of distributions. Our learning target is I can describe and compare shapes of distributions. So we have two different types of shapes, two main categories. Those are symmetric and skewed distributions. We're going to talk about each. So here this represents a distribution that is skewed left. The tail is kind of the skinnier part of the distribution, extends to the left, and most of the data, the peak of the data, is on the right. Symmetric distribution has a left side and a right side that are basically mirror images of each other. And data that is skewed right has a tail on the right, so the skinny part is on the right. Most of the data, the peak of the data, is on the left. So we'll want to refer back to these when we're trying to decide the shape of a distribution. So example 1, describe the shape of each distribution. Well, the first one, it has a tail to the right and most of the data on the left. That means it is skewed to the right. The tail's to the right, it's skewed to the right. And we can see it does match that picture well. If we follow the curve of that, it's very similar to this. And part B, this distribution actually looks pretty even on both sides, so I would call that a symmetric distribution. They're almost mirror images of each other. Not exactly, but pretty darn close. And example 2, the frequency table shows the ages of people watching a comedy in a theater. Display the data in a histogram, then describe the shape of the distribution. So generally to describe the shape of a distribution, it is helpful to have a visual like a histogram or a dot plot. In this case, they asked us to create a histogram. So let's do that. So we're going to have two axes. The one on the bottom shows the intervals. The intervals are ages. So put ages. And I have 1, 2, 3, 4, 5, 6, 7 of those. So I'm going to put like 7 little tally marks so I can see the 7 intervals. 1, 2, 3, 4, 5, 6, 7. And then I'll label each. So the first is 10 to 13, then 14 to 17, 18 to 21, 22 to 25, 26 to 29, 30 to 33, and then 34 to 37. And then on the left-hand side, I'm going to put the frequency. So the frequency for each of those intervals. The highest frequency is, let's see, 20. So what I'm going to do is I'm actually just going to put 10 tally marks and make each worth 2. If there's something that's in between 2, we'll just put it halfway between. So all the way up to 10 tally marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 right at the very top there. And we're going by twos. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 at the very top. Now I'm going to fill in the bars. So my first interval, ages 10 to 13, has a frequency of 1, so that's just going to be below the 2. My next 14 to 17 has 3, so that's halfway between 2 and 4. 18 to 21 has 7, so that is halfway between 6 and 8. Next, I have 22 to 25, which had 12, a frequency of 12, so right on that line, 12. 26 to 29, there were 20, so that goes all the way to the very top. Next, I have 30 to 33, which had 18. And finally, I had 34 to 37, which had 3. Okay, and let's also not forget to give this a name. I'm going to call it comedy attendance because it's describing the attendance at a comedy show based on age. So here's our histogram. Now we're going to describe the shape of the distribution. So even though there's a lower bar over here, it still seems that most of the data is in this area on the right, and there is a tail over to the left. So that matches our skewed left distribution. So we're going to say that this data is skewed left.